Good morning and welcome to 1Spatial's event for the public sector. It's great to see so many of our friends and customers already logged in, and I can see that there's some new names logged into the webinar, which is great. Over the next 2 hours, we're going to look at how having a sustainable digital world that mirrors our physical worlds helps organisations to deliver services that support sustainable goals. And we're also really excited to be sharing with you some of the innovations that 1Spatial have been working on over the last 18 months. So if you have any questions through the day or over the next 2 hours, if you want to just use the message window to raise any questions that you have, and then what we'll do is we'll do our best at the end to answer those questions. But if we don't have time, what we'll do is we'll definitely follow up with you later via email and to get those questions answered. I just want to start by running through the agenda for this morning. So I will be setting the scene by looking at how a sustainable digital world that mirrors the physical world can help us build sustainable services. Then we're going to have Bob, our CPO, and Seb Lesware, our CTO. They're going to introduce the new 1Spatial platform, and they're going to demonstrate how through the use of location master data management principles, we can deliver sustainable services. We've then got Phil Ridley, who is going to do a deep dive into the new data quality hubs, explaining what they are and how they support organisations to deliver coherent data. And he'll be using the police data quality hub as an example to show how forces are using these hubs to deliver safer communities. We then will take a 5-minute break for a quick cuppa before returning, where John will be showing us an example of business applications that use the 1Spatial platform to deliver domain-specific solutions. And then finally, we're really privileged to have Carsten from the Ordnance Survey, who's going to talk about how we have merged the capabilities from the 1Spatial platform with the capabilities of the OS platform to deliver joint services. So before I get started, I just want to do a quick introduction, or take this opportunity to do a quick introduction to the 1Spatial government team. So my name's Dan Warner. I head up the government team, and I focus on working with the mapping agencies and the defence agencies. We have Fiona Newson, who is our marketing lead and is responsible for all the content and webinars and blogs that we generate within the government team. Then there's Phil Ridley, who's Senior Business Development Manager for our Blue Light sector, and then Matt White, who's Senior Business Development Manager for central government and the environment agencies. So, unlocking a sustainable digital world. If we're going to be successful in delivering a prosperous society that safeguards the natural world, then we need to ensure that the built environment is... Oh, have I lost the screen there?
Yes, Dan.
Yeah, I can't see your screen right now.
Right, okay. Just bear with me one moment. Something has happened technology-wise. Okay, can you see it now?
Yeah.
Sorry about that. So, so where was I? Yes. So, if we're going to be successful in delivering a prosperous society that safeguards the natural world, then we need to ensure that the built environment is organised and coordinated in such a way that it's designed to enable our communities and nature to develop side by side. But if both these natural and built environments are complex and interconnected, therefore the services that we deliver, be that transportation or utilities or agriculture, if they're going to be delivered in a sustainable way, they can't be isolated from each other. And the best way of delivering decisions that are informed is by making those decisions against digital representation of these interconnected physical environments. So if we can map the relationships within the built environment and between the built and the natural environment, then we can deliver services that deliver against the sustainability goals. So as a group of geospatial experts, we've been capturing these digital representations of the built and natural environments ever since the very first digital map. And these are very often digital maps have been used to deliver a single output. So it might be that we've used them to work out a type or size of an asset from which the asset owner is given a grant or maybe is charged a tax. And typically in these scenarios, that data is maintained just to serve one purpose. And the consequence of that is very often that data siloed. It's also not uncommon for the built environment to be managed in isolation to the natural environment. And it's not uncommon due to commercial sensitivities that the built environment, for example, utility networks, are not interconnected between organizations. But if we're going to deliver sustainable services, then the digital representation of the built and the natural environments need to match the interdependencies within the physical world. And to deliver the interconnected digital services, we need a digital world to be sustainable. And this requires a platform that delivers the right data to the right people at the right time. And for this to happen, it needs security in how data is maintained. And in the interconnected world, it needs that security in how that data is distributed. But data needs to be findable. And where data is pulled together from different sources, it also needs to be mastered to ensure that that data is consistent and coherent. And with data being moved between interconnected systems and platforms, then they need to be built around, those platforms need to be built around core data ethic principles. So then we have interconnected systems and data interoperability from which the services can be delivered, and those services can deliver greater insight. And by having these sustainable platforms, we can bring the physical and the digital worlds together. By having interconnected systems, so system of systems, our digital worlds can represent some of the complexities and some of the interconnections of the physical world. And we see this already with smart cities and digital twins. These system of systems means that we can foster collaboration between organizations. This enables government and the commercial sector to deliver better services to the public by that data integration. It also enables platforms to aggregate that insight from a national picture down to a local picture. And then once we have that, we can then build applications that draw all this data together to enable decisions to be better informed. And we're seeing these applications already happening today. We're seeing across Europe the rise of the asset registers to improve the efficiency and safety of delivering utility services to the public. These are offering connecting data from many organisations into one portal, and Carsten from the Ordnance Survey is going to go into far more detail on that later on. We're seeing master data management platforms help integrate services between government departments, ensuring that assets are represented consistently between those departments. With regards to the environment and countryside stewardship, there are growing needs to develop sustainable worlds of our natural environment. This is driven by the Green Future Plan and the need to understand the quantity, quality and location of our national assets. And finally, the UK government's 10-point plan for green industrial revolution is in part looking at how we can protect the environment. So developing sustainable digital worlds that's safeguarding the natural and built environment from the impacts of climate change. And so therefore we're seeing examples where the investment in flooding and coastal defences needs to take an asset-based approach to doing that. So that's sort of an overview of where we see sustainability and sustainable digital worlds and the need for a sustainable platform. Now I'm going to hand over to Bob Shell, our Chief Products Officer, and Seb Lesfair, Chief Technology Officer, who are going to introduce you to the new 1Spatial platform and how we're using that to help our clients deliver sustainable goals.
Thank you, Dan. Good morning, everyone. So I'm going to just set out a bit of information about the 1Spatial platform. So as Dan has been talking about, an important part of sustainability and making the data sustainable is an approach that we call location master data management. So the 1Spatial platform has a series of components that help you to create intelligent data strategies to make sure that data's current, it's consistent, it's coordinated, and it can be trusted. And so the 1Spatial platform is available as a SaaS platform in the cloud, also on premise, but to be able to master the data on any device at any time. And what it combines is a series of capabilities made up of primarily two products. So one data gateway, which is essentially the front door for controlling who can access what and when and what they can do with it. And underneath it, our rules engine and API will integrate. And the key thing is those rules which allow us to check the quality of the data and improve the quality of the data. And then from those components, we build up data quality hubs. So for example, the police data quality hub that Phil's going to talk about, or a defense data quality hub, or a planning hub, as well as other location-enabled business applications. So specific solutions doing a specific task that 1Spatial builds that has the data and the capabilities already there ready to use. So for example, water pipe leakage detection, or positional accuracy improvement, or ecology survey submissions. And then as well as those components, then we have SDKs to allow those capabilities to be available, for example, on a mobile device. The key part of the capabilities is that they are available on premise, so that's on your platform, or it could be on your cloud or on our cloud. And the key thing is that they're scalable. They can scale according to the usage demands of the users. And they are underpinned by our no-code rules engine that provides validation of data and enhancement of data automatically using defined rules that experts have specified, or data, people who know the data have specified, but also machine learning techniques for inferring rules. And from these, we can build business-focused applications that 1Spatial can build, or our customers can build. And these do, when 1Spatial builds these applications, they're pre-configured for specific tasks. And a key part of this is access to all sorts of data in all sorts of places. So data connectors that can connect to data from a variety of places, and then write rules to compare, to cleanse and match and merge the data across these different sources of data. And all of these components are available with APIs, so to allow seamless integration with other 1Spatial components or with third-party components. Just wait for the slide to change there. Bob, I'll hand over to you.
Okay, thanks, Seb. So Seb mentioned at the start some of the different products that make up the platform. And the first one I wanted to give people a little bit more information about is the product called One Data Gateway. So that serves kind of two purposes, and we'll have a little demonstration of that as well. But really, it's the product that gives us that self-service portal. So Dan mentioned that it's important that data and is accessible and interconnected, but that's also true for the actual services that you want to use. So to make sure that through a portal, we can give access to the right applications so that the applications are both findable and accessible. And those applications, we've touched on it already, but they're looking at things like spatial validation routines, data improvement operations, anything where you might be able to link it and control it through a rules catalog to look at things around standards compliance. So what the portal allows you to do, so the applications that we drop within the portal, they basically run intuitive workflows. So Dan mentioned again about making sure that data was not just QA'd, but actually systems were connected and data's connected and joined up. So you'll see that as we go, when we look at the demonstrations, it's all around submitting some data for the particular processing and make sure that data can make it safely in a controlled way through your supply chain. The One Data Gateway product also gives us access to review what we're doing through dashboards. So there's nice quick ways to go and have a look at what are the quality levels of the data that I'm dealing with, whether it's your own information or data that's been supplied by third parties. And Seb's touched upon a point there which applies to all the different products that we're going to briefly mention, that there is that flexible deployment. So you've kind of got access through One Data Gateway to unlimited users, and as Seb mentioned, whether that's in the cloud, an environment that you decide you want it on premise or within your own individual cloud. And we'll also touch upon how some of these applications are grouped into hubs. So this is the kind of background to One Data Gateway and the things that we were talking about with some of the capabilities and features. And this is just the first little shot of how you might use one of those apps. So here I'm using the ecology survey application. I'm just making a submission where I have to drop my data that I've used to capture the information for my ecology survey. I'm asking that now to be processed. This is where that intuitive workflow in the background is going to say, okay, I've been given some data. The data matches what the application was expecting. Once we've confirmed that, that intuitive workflow just runs and the data will be processed. And at this stage, you can see you've got your report on what's happened. We can see which rules are passing and failing. We can go and have a look at the data on a map if we needed to, or in this case, complete submission. Once that submission's been completed, you've then got quite a few different options to either download a simple report about that submission. So here I can go and have a look at the metrics about what's been performed. That can be then saved away and downloaded as a PDF for your own records and your own audit. Or your other option, if your data's been fixed or corrected, means you could actually output that data in the format that you received it. So the view report is that's something that quite a lot of people have asked for, this typical report of your audit history of what's happened and how it's been processed. And like I say, the other option that most people are after is the data that I submitted, can I have that data back, but with the additional information of either improvements that have been made or specifically marked up areas in the data for us to process. Now the second part to Data Gateway, the portal bit, which is all around a lot of the user management applications. This is the second part that we want to just talk people through. So this is where what we actually do is group users, so everybody gets allocated onto the portal, and you can go and control all your usual things like your own avatar, some of your own styling and your look and feel that you want from the application when you set it up. And we also create what we call suppliers. So the suppliers are where we then associate individual users to a particular supplier. So who's going to be using these applications and these hubs to supply data to run through those intuitive workflows. There's other system configuration parameters that we have. So the applications run against the rules engine 1 integrate. We can set up configuration so it hooks into your own systems like LDAP. And then the actual workflow themselves get grouped into what we call projects. So here, this is that ecology survey project that I showed you before. You can set up and control what the images look like. And behind that actual project is the detailed specification. So you can define, once a user uploads some data, how long does the system keep that data for? So does it keep it within a week? So you can go back and see what you did. What data is expecting it to be supplied? Once that data is actually supplied, what are the rules and the specifications that would be run behind it? And if you wanted to attach other PDFs or other information to that application, you can do that there. And then the last part that we mentioned before, and this is where you can go in and have a look at how everything is performing, is a dashboard view of all the submissions that may have taken place across the different projects, across the different specifications. So you can drill down and see how active that application is. Are there any particular areas that people should focus on for editing or data improvement? And if you want to, you can download all those stats and metrics to use in your own dashboard systems. Something that Seb mentioned as well earlier was there's an API surrounding all of this, so you can actually plug your own dashboard systems into One Data Gateway using the APIs.
So Bob's been describing One Data Gateway, which is the front door to access the rules, but underpinning it is the OneIntegrate rules engine. So this is the rules engine that we use, for example, to build a data quality hub, where a data quality hub is not something where you go and get the data, it's where something that you submit the data to and say, can you validate this data? Give me a measure of data quality. Or could you even measure the data quality and then fix it according to rules? And this is our no-code rules engine. So 1Spatial can write the rules, or customers can write the rules themselves. They don't need to be programmers to define what they need the rules to do. And then once you've got the rules written, you can run them against the data, and that will measure data quality and give you those sort of drill down, detailed reports that Bob was just showing. So fixing data and enhancing the data. And what that gives you is essentially a form of knowledge management, because then the rules that are typically in people's heads or embedded in specific bits of software are centralized in a single place. They can be collaborated on and shared and used across all systems, with APIs available to integrate and data connectors to connect to the various bits of data. So let's have a look at an example of a demo using OneIntegrate. So here we've got an example of this is a session. A session is a series of tasks that we do in OneIntegrate, and the tasks that we're doing are opening two different sources of data, and then running a series of rules and a series of improvement rules that we call actions. So here we're running opening a few thousand records, and these happen to be predominantly spatial data. So this is spatial data checking that we're doing. But the same applies to the data spatial or non-spatial, and typically you'll find it's a combination of the two. So data that contains a geometry but also attributes, it's important that we process them both and take them both into account. So here we're doing a series of checks on the data. So for example, do my geometries overlap? And this data, we'll have a look at it in a moment, it represents both 2D and 3D buildings for the same area, and we're going to do some processing and some checking on them. So we're doing some initial checks like, do they overlap, are they valid? And then we're doing a series of checks that look at the consistency between the two different representations of the same data, 2D buildings and 3D buildings, and we're seeing, do they match? Do they match exactly? Does the footprint of the 3D building match the 2D building exactly? And if not, well, does it match partially? Because what we see in these examples is if you have rules that are fairly crude and simplistic, you'll find lots of your data doesn't meet the rules. But when you look at it, you think, actually, no, that is valid because there's a subtlety I haven't thought about. And so that iterative process of defining the rules and getting them right so that what it reports are genuinely problems that you care about is quite important. So if we have a look, so we can see the data here. So we've got the grey building footprints, and in green we've got the 3D buildings. And the 3D, these are often captured and managed in slightly different processes using slightly different tools. So here is an example of an overlap. These two buildings are very subtle. You can't see it visually, but those two buildings have a slight overlap. So detecting it automatically is important because as a human, you can't necessarily detect these issues that might cause downstream problems in your data processing and what you do with them. And then we're doing a check to compare the 2D building footprints. Do they match the bottom of the 3D buildings, the footprint of the 3D buildings? And what we find is if we compare them exactly, we find none of them match, and that's to be expected because just the subtleties of how the data is captured and managed and encoded. And so what we're interested in is find me anything. So we modify the rule to say, well, find me anything where not that they match exactly, but they match to within 30 centimeter tolerance. And here we see different examples of why they don't match. Now, in this example, we see there is a correlation. There's the grey 2D footprint. It's pretty much the same shape and orientation and size as 3D building. It's just positionally offset. And that's because the 3D building's been captured with some very precise, sometimes centimeter level laser devices. And the 2D footprints are often maybe 30, 40, 50 years old. Here are different examples of where there are subtle mismatches between the data. If we keep stepping through these examples, now here we see an example where this is a temporal mismatch. So this is where the data is more up to date in the 3D data set. So we've got some smaller buildings that have been knocked down at some point and replaced by a new building. And now, so this is giving us change intelligence. So it's not just that maybe there's a problem on the data sets, it's actually maybe there's some out of date data. So now we can think about maybe we want to create some rules to automatically remove those 2D buildings and replace them with a building we've extracted from the 3D. Here we can see some subtleties on the encodings. We've got some buttresses or maybe they're doorsteps in the 2D data that aren't represented in 3D. So again, it depends on the data and how it's captured. Maybe that's intentional, so we can modify the rules to say, well, actually don't consider those. Because the 3D data captures data according to different specifications to the 2D data. And so when we add a bit of fuzziness, rather than telling us, well, everything's different, it's showing us whether there's anything significant in the data. But we can use rules not just to detect the differences and detect the mismatches in the data, but also correct one data source based on another. So here's that area where we had a positional offset, where we had some 3D buildings that were positionally offset from the 2D buildings. And we can create rules that will automatically shift the 2D buildings into the correct position by identifying the correlation. So these buildings in 2D and 3D don't have common identifiers at the moment. And actually they're modeled in different ways. So a collection of 3 buildings adjacent to each other. In 3D, that's one big structure. In 2D, that's 3 separate buildings. But we can automatically infer the shifts to get from 2D location to the 3D location, and then automatically shift the data. If we step to that, we can see the 2D buildings have shifted underneath the 3D buildings. They're no longer visible. But importantly, where we don't have information about the shift, we've created those red dots, those pins that pin the data in place. So we're only shifting the data that in our rules we've decided we want to update. So that's an example of data improvement, using rules to improve the data. And because we've improved the data, we can now, because we've got validation rules, we can now measure the quantity of that improvement. So we can rerun the rules before the shift has happened, before the updates has happened, and after the shift has happened. And those data updates can be all sorts of things. They could be, here we've got an example of positionally shifting the data, but we could be correcting attributes, we could be updating classifications, we could be creating new buildings where there weren't any before. And we can now see, so here we're showing, we've run the conformance check. So we had an 81% conformance before we did the automatic shifting. And then after the automatic shifting, we're rerunning the conformance, and that conformance has now jumped to 89%. So we've improved the data from 81% correct to 89% correct according to our rules. And that's a check that we can keep running over and over, and we can see how the data improves over time, and apply automatic rules to correct it, but also where it can't be corrected automatically, send those reports to users who can then do the manual correction.
So that's where we've got both the One Data Gateway product to give us that portal, that kind of front door, as Dan was describing, to the applications and intuitive workflows. And those workflows run and perform just as Seb was showing with One Data Gateway in the background. And what we've been able to do through the One Data Gateway product is actually group common intuitive workflows together and actually group them into what we've been referring to now as data quality hubs. So we've been able to pull things together around common domain-specific use cases and just offer those out to people in a really quick and fast way, because we can deliver it all through the cloud. And you've got all your dashboarding capabilities to understand and track any of the data quality management or the data improvement processes that you might want to set up. So some simple examples of what Phil will show and talk about in a few minutes is around the police data quality hub, where we've got a few different applications that people can choose which ones they want to perform slightly different intuitive workflows on their data. We've also got another example from the utilities space, which allows us to group common things that utilities look to perform. So pipe inference, leakage, positional improvement is also one of those things. And we've also got another example of a hub looking at different types of BIM data that we might want to QA and perform some measurements on before we use it in our actual systems. So different types of hubs are springing up for different areas. The other thing that we've also built, which we mentioned at the start, is not only the hubs where we use to group things together, but also different business applications as well that are also built off the platform. So John Hartshorn will talk about one of those later on around traffic management planning, but these are all just areas where we might want to deliver some other sort of real-time insights to our customers, but rather than it being through just a straight data supply chain operation, there might be a different type of user interface involved, where a user got to put some information into the system through a map, something like that. But the same rules engine and the same security measures and scalability that the platform offers allows us to deliver all of those things. So one example of those applications could be traffic management plans, which we will talk about shortly. We've got another one, although we've got the BIM hub for looking at the QA and the measurement of all your BIM related data. We've also got a facilities management application called Real World 4D, which allows us to join the 2 and the 3D worlds together. We looked at really briefly earlier the example of our ecology survey solution. And we also got a number of different mobile solutions which we built using the SDKs which are available on the platform. So incident management is one application, as well as others that we have that are available around creating mobile editing applications. And I'll just give you a quick example of one of those now. So here in this mobile application, it's all about building something that's really targeted for the users. So this is for performing editing out in the field on something like an Android device. Here we're actually downloading and accessing the data that we need to perform that job. And this is completely tailored for this specific operation around how can we go and do some editing in the field. Very targeted application. The editing can then also work and be controlled offline. The same rules engine is in place to allow us to capture the information correctly. We've got some pretty common and popular features around changing the overlays and backdrops to help the users out in the field perform the specific job. And this is also through the platform and the APIs and the integration we've got. But Seb mentioned one around the data connectors. This example actually hooks up to an Esri backend system. So it's using the Archer stack behind the scenes. So here you can see we're quickly capturing some data, changing between the base maps to make sure we capture it correctly. Really simple undo and redo buttons, so we can make our edits pretty seamless and quite make sure that not just the workflows, but the user experience and the whole UI is really intuitive for everybody. And so we can go and simply perform our edits, save them away into the system. Here's examples where the rules engine is saying, well, you've got more things to do before we can make sure that data is being captured right first time out in the field. So a really simple example of where the SDK is being used to build out some targeted applications.
So we've talked about the data quality hubs and business apps, and then the third strand to this is partner solutions. So everything we've seen, the capabilities are available that are also then embedded, either integrated with partner solutions or embedded with someone else's application. And we'll see an example of that in a moment or later on when Carsten will present the Ordnance Survey partnership application. So the energy system map example. But through those APIs, that means all those capabilities can be delivered, used by the people, accessed by the people, or embedded within a system where the rules engine is not necessarily even visible, it's just running in the background.
Thank you very much, Seb. Thank you very much, Bob. Thank you very much for that insightful presentation just now. So we just want to shift gears slightly now for you all this morning. So now we're going to have a session from Phil Ridley, who's Senior Business Development Consultant at 1Spatial, focusing on data quality hubs. So just a brief intro about Phil. Phil, as I said, is Senior Business Development Consultant at 1Spatial. Phil's taking the lead on one of 1Spatial's new sectors, which is policing, helping police forces across the UK to implement the National Digital Policing Strategy by ensuring that data is of a good quality. Phil is also a member of Tech UK's Interoperability in Policing Working Group, and prior to working at 1Spatial, Phil was a geospatial intelligence analyst.
Great, thanks, Matt. I hope everyone can hear me okay. Welcome everybody to this part of the webinar, which is going to be focusing on the data quality hubs, which is part of 1Spatial's platform to make location and master data management as available as possible to all organizations, wherever they are on their data quality journey. So why are we here? Well, the world is becoming ever more digital and ever more reliant on data-driven processes. We see it in our everyday lives with tailored advertising, Google Maps and statistical dashboards being presented on daily news bulletins. Fundamental to this is the ability to use and share data for a connected society using the data with confidence. This requires data to be not only of good quality, but also compliant with standards. Standards enable the data to be shared, and by having data that is standards compliant and of good quality, we can start to connect systems for automated processes, which ensure the maximum return of investment on all technology. And I saw a quote recently which summarized it really well. It says, the use of data standards enables reusability of data elements and their metadata that can reduce redundancy between systems, thereby improving reliability and often reducing cost. We're seeing an increased recognition of the importance of good quality data and standards compliant data. However, undertaking data quality projects, and particularly large data quality projects when you're trying to achieve everything at once, can often be met with hurdles. And those hurdles can, I think, be summarized into three categories. One is budget. We're coming out of a pandemic and budgets are inevitably going to be tight. It's often difficult to get budgets for large projects and large scale data quality programs. So how can we find ways to split these large programs up into bite-sized chunks that are easier to tackle one bit at a time? Logistics. Also, large data quality projects are complicated, and when planning or implementing projects to try and cover every single data quality problem there is, you often find for every question answered, there's another 6 that need addressing. So it's complicated logistically to pull this off. And time. Everyone is busy, and given the complexity of large data quality projects, large scale data quality projects, it can be difficult to find the time to actually even implement the programs. So we all recognize the need for good quality data, and so how are we going to overcome these barriers? Well, 1Spatial's data quality hubs overcome these barriers by providing a simple to use staged approach to data quality. With a pay-per-app licensing model, organizations can work through their data quality projects in stages using use case targeted apps. The result is organizations being able to tackle data quality programs and ensure data becomes a true enabler by focusing on one use case at a time and only paying for what they need. Therefore, it simplifies the logistics, it saves time, and it avoids a large bill. At 1Spatial, we're developing multiple hubs for different sectors designed in collaboration with the users in those sectors to be an ever-growing data validation and cleansing service for users to start on their data quality journeys. So I should point out, these hubs are designed with users for users. So the apps are continually being developed and the app libraries are being extended. And these apps are being developed with the users to make sure they're always relevant and current and relevant for users. So we're constantly adapting and developing them. If you want to have a look at one of the hubs that we've got live on the website, why not have a look at the app catalog for the Police Data Quality Hub on 1Spatial's website. I should point out that we're also starting to collaborate with partners to integrate these apps on data quality hubs into wider infrastructures. Again, this is helping improve interoperability and the sharing of good quality data in systems of systems. Now, we've got multiple sectors on the screen, but one sector I'd like to focus on for a minute is policing, as this is one of the sectors we've been early adopters of the Data Quality Hub. In policing, data has been highlighted in the National Policing Digital Strategy as a key enabler, and the importance of data was demonstrated with an entire day dedicated to data at the 2021 National Police Digital Data Summit. Good quality data in policing enables the successful implementation of the POL model, which is people, objects, locations, and events. And I always like to think of POL as if I was playing a game of Cluedo. It was Colonel Mustard in the kitchen with the candlestick, and the event was a murder. The key to piecing any event together is location. Everything happens somewhere, which makes the location aspect of policing critical, whether you're a detective trying to piece together what really happened during a murder case, or an operator trying to get first responders to an incident. It all requires data and it all requires an element of location. Additionally, senior officers need to proactively understand where to send a finite resource of police officers and equipment. This is guided by hotspots and using patterns and trends to predict future crime events and what resources need to be deployed where. Location data is critical to ensuring officer time is used as effectively as possible and public and officer safety is maintained. This is why data is being listed as a key enabler in the National Policing Digital Strategy, supported by the National Police Chiefs Council. And by ensuring data is of good quality, standards compliant and made available, police forces can start to connect their systems for a complete, correct and current picture of what is happening where. For example, business intelligence dashboards connected to records management systems, pulling data through to give officers a clear picture of what crime is happening now, what the patterns and trends are, and where to deploy their resources next. This connectivity is great and gives users a rich tool set. However, it's only as good as the quality of the data that's being used. It comes back to the old saying of rubbish in, rubbish out. And the more data is being shared, the greater the magnitude of the problem. However, large interoperability and data quality programs are big projects to undertake, both financially and also logistically, as I mentioned earlier. Where do you even start when you have millions of records and lots of use cases and scenarios to consider? And during the past year, 1Spatial have been working on a proof of concept with Avon and Somerset Police, looking at how the 1Spatial technology can ensure continued improvements in the data quality of the force's records management system. And the results of that were great. We managed to improve the quality of the data by over 50%. So over 50% of improvement of number of records that were compliant with the rules that we laid down. And we processed nearly 100,000 records in a matter of minutes. So when we talk about the data quality hubs and what they are on the 1Spatial platform, the Police Data Quality Hub here, as Bob mentioned earlier, is a series of apps. It's no code. As you can see from the screenshot on the screen, anyone can use this. You can log in and click through, as we saw in the demos earlier, and know exactly what is going on. But one of the critical things here is you're only paying for what you need. So every single police force in the country has different data quality priorities. And by taking this hub approach, you only need to pay for the bit that you need to focus on. So, for example, if a police force has recognised that they need to have a focused project on improving the records to make sure that they all have the correct UPRN, they would only need to pay for the UPRN app. Another example is the coordinates. If there's been some errors in the geocoding in the past, you may want to purchase the coordinate correction app to run your data through. You don't need to pay for absolutely everything, only the apps that are relevant. And this app library, we're continually evolving, as I said earlier. We've got our members community, and we've already drawn up a list of apps that we want to consider applying to the hub. For example, nominal data cleansing, and then connecting to other systems, such as potentially ordnance surveys, emergency services, gazetteer, and integrating the different systems. These are all different apps that we're looking at with our members and with our partners to see how we can improve and make sure that this hub continues to be a rich resource. As I mentioned, you are becoming a membership of a community. These apps are built with the police, for the police. No one's going to know the data quality problems or the interoperability problems as good as the member police forces, and they are advising us with our partners on how we can work to improve the quality of the data, but also help improve data sharing between systems to get that joint up interoperability that's going to ensure maximum return of investment for police forces in the technology that they have purchased. I mentioned the constant evolving library of new applications made available, but there'll be never pressure to buy more apps. You only need to buy the ones that are relevant. There's also dashboarding capabilities, as well as membership of the community and workshopping and coming to events for our members where we look at how we want to evolve the app library. The dashboarding capabilities are built into the hubs, allow users to look at where the data quality problems are in their organization, and that helps inform where the apps need to be focused and how apps need to be refined, or where new apps need to be developed to ensure data is of the best quality possible and is fully interoperable with other systems. All data quality transactions are fully audited, and this is especially important in the police because we want to ensure that everything that happens to data is fully audited, so it's fully transparent. So if there's ever a case that needs to go to court, we know exactly what's been going on with what data, so that there's full confidence as the data is used as evidence. And as I said before, there is a high performance output on the no-code solutions. In the proof of concept, we managed to get the number of records with the correct UPRN and a correct coordinate up to 74 or 75%, often processing on over 90,000 records and getting improvements in a matter of minutes. So here are the results of the proof of concept. As I mentioned, the UPRN was the one that I liked most because it had the best results. But you can see that vast improvements, over 90,000 records in just 10 minutes. So as we've been developing the Police Data Quality Hub, we've seen great enthusiasm from members and organisations who understand the value of good quality data, but are not yet in a position where they want to just go for it with one big, large data quality program. They want to take this bit by bit. And we're talking currently to between 8 and 10 police forces who are at the very early stages of just looking at where their data quality programs can go and how they can improve the quality of their data, start improving interoperability between systems. And from this, part of this enthusiasm was we're also in the early stages of planning a national campaign with the Police Digital Service to encourage police forces to enroll to the hub and start to run data quality projects and join the hub community. As the more organisations that join this and start getting involved, the better, the richer the tool is going to get as the more use cases that we've got and the more apps that we put on. But it's not just policing who are looking to adopt the data quality hub component of the 1Spatial platform. You'll see on the screen that we are also looking at other sectors, including planning, defence and environmental. Many public sector organisations at local, regional and national levels have responsibilities for safeguarding our natural environment, playing a major role in people's day-to-day life, from the food we eat and the air we breathe to the water we drink. 1Spatial works with public sector organisations responsible for safeguarding our environment across the UK, including the Departments for Environmental, Food and Rural Affairs, Environment Agency, Natural England, Natural Resources Wales, Rural Payments Agency and the Department for the Environment, Agriculture and Rural Affairs. Quality data about our environment and environmental assets is needed for evidence-based decision making and monitoring changes to our environment. Organisations depend on accepting and assuring environmental data from internal and external sources to build and maintain environment asset registers. For example, natural capital asset registers. And for that one, on the environmental app, we're putting together apps that are termed under natural capital asset apps, which have various standards or rules that need to be validated before data can be submitted to the natural capital asset registers. Environment-based data quality hubs assure incoming environment data from internal and external sources using agreed business technical rules. Another example is the Environment Agency, who are using rules to assure incoming data about flood and coastal defence assets and maintain a flood and coastal erosion defence asset register. And here you're looking at geocobi data. So one of the things we're putting onto the Environmental Data Quality Hub is an app to validate your data against geocobi. So is it of the correct schema? Does it meet the requirements to be valid geocobi data? And that's the geocobi app. Another example is Rural Payments Agency, using rules to assure incoming data about farmer land parcels and land cover and maintain a land parcels asset register. Again, we're putting onto the Environmental Hub land parcels and land covers app for farmers to use. So the farmers are only paying for or the farmer agencies are only paying for the apps that are relevant to them. 1Spatial's data quality hubs for environment data enable organizations to maintain authoritative data registers pertaining to our environment. And I mentioned there's a number of examples of the apps that we're putting onto the Environmental Hub at the moment. We're taking a similar approach with defence. We're building a defence hub and also planning, looking at various standards and rules that are required for planning data to be submitted to national data sets. All of these data quality hubs enable organisations to have good quality data to underpin a sustainable digital world without the need to invest in long, complicated and expensive digital transformation programs. It's making the capabilities of location master data management accessible and affordable so that organizations can achieve and enjoy the benefits that good quality geospatial data can bring to help underpin a sustainable digital world. Now, as Dan mentioned at the start, we're having a quick 2-minute break. So go and grab a coffee, and then when you're back, we'll be hearing from John about some of our business apps on the 1Spatial platform, and Carsten from the Ordnance Survey on how Ordnance Survey and 1Spatial have been collaborating between the 1Spatial platform and the Ordnance Survey technology on projects, on various projects. So see you all in a minute.
Good morning again, everyone. Hope you managed to grab a drink, a tea or coffee. So we'll get started again for the second part of our webinar this morning. So secondly, what I'd like to do is I'd like to introduce my colleague from 1Spatial, John Hartshorn. John has worked in the field of geographic information for the past 30 years. He's been at 1Spatial for 11 years, having worked closely with customers throughout that time. He's now Senior Product Manager, looking at products and services that solve specific problems using spatial data and 1Spatial's platform technologies. John will be talking to us about a 1Spatial platform business app example. Business apps are typically applications where a user logs in automatically to achieve a specific outcome, normally done by inputting information via forms to achieve the same desired output. Just to note that OneIntegrate is a core product of our business apps. Ensuring that data is findable, accessible, interoperable, and reusable are key aspects of digital world, and business apps automate data from a fair perspective to deliver specific outcomes. And I'll now hand over to John, who will take us through a business apps example. John.
Thank you, Matt. Good morning, everybody. I had hoped to set you a little task to see if you could guess what the map was behind me, but I noticed the sun's finally come out in North Yorkshire and it's glaring away there, so you can't actually see, but I'll tell you at the end if I remember. So just as Matt said, I'm going to talk you through just an example of one of our very use case specific business apps that is built using our 1Spatial platform. And just to set the scene, every year in England alone, let alone the whole UK, there's around 2.5 million roadworks that require some kind of notification of those roadworks going ahead. Often known as street works, they're carried out by organisations referred to as statutory undertakers. And these include utility companies and other infrastructure owners and operators, but also the local highways authorities themselves. Now, statutory undertakers are identified under what's known as the Streetworks Act. So those are people who've been given the statutory right to dig a hole in the road. But in addition to the statutory undertakers themselves, there's many contractors undertaking street works for and on behalf of those statutory undertakers. Obviously, street works are necessary in the course of maintaining and provisioning infrastructure, such as everything from street lighting through to your cable television, your cable internet, but also all the pipes and wires that bring power and water to us. But actually, the number of street works is likely to grow over the next few years. There's going to be more and more infrastructure rolling out in relation to electric vehicle charging provision, but also a number of district heating applications or distribution networks are in the offing, and probably happening before the COVID thing, but maybe accelerated by it. We're likely to see more and more active travel schemes as highways authorities look to repurpose some of the street with a bit more of a focus on cycling and pedestrian. And whatever the drivers behind changes that result in street works, there's also a growing number of highways authorities who are implementing lane rental schemes, and that means whoever's digging the holes in the road can be charged up to about £2,500 a day for every lane that they're using, particularly on a busy road, particularly at peak times. And almost all of these street works require health and safety measures to be put in place around the works, and a lot of those specifically require a design for the proposed signing, lighting and guarding equipment that's going to be used to protect people and the workforce. So the use case here is All of this stuff needs to be laid out in the street based on a bunch of rule books. And there's actually one here called the Code of Practice, or known as affectionately as the Red Book. And this is actually legislation. This actually provides information as to how you set out the equipment at streetworks for signing, lighting and guarding based on the layout of the road. And it's backed up by a couple of technical documents. The traffic signs manual goes into great detail, but also for very specific things like the traffic light control, that there's some technical information that augments the Red Book and provides all that additional detail. Now, I mentioned the Streetworks Act. That's actually, there's a list of codes of companies who are allowed to dig up the road, but also in addition to all these sort of rules and legislation, some of the regional highways authorities and transport fours also extend the rule set with some sort of localized specific versions of them. So from our point of view as a rules-based company, or a company that produces software that implements business rules, it's a really good classic use case here, because we've got some rule books that we could potentially encode. So the way it's normally done is the top two photographs there actually show what's in the Red Book. It shows just an example of an idealized road layout. And a set of rules to the left providing the detail, and you can see the measurements as well. It's typically done in CAD systems, so although there's a little bit of automation and templates and symbol sets and drag and drop, it requires a lot of knowledge of the Red Book, and it's typically done manually in CAD. And that kind of brings a few problems in terms of inefficiencies. You can produce one of these things in maybe 30, 40 minutes, a couple of hours, but depending on how your supply chain is structured, it could be that somebody further down your supply chain in your contractor community is responsible for producing these, or even has a specialist outsourced provider. So the turnaround time, yes, it could be half an hour to 2 hours if somebody's sitting at the desk next to you, but it quite often can be up to a couple of weeks to get a good turnaround on a completed layout. So that sort of begs the question, is it possible to actually speed this process up and make it more efficient and more collaborative? And in that respect, one of our customers, one of our utility customers, Northern Gas Networks, it actually approached one of its innovation bodies that it's part of, the Energy Innovation Centre, and effectively posed the question, like, you know, is there some funding available for us to work with somebody to see if it is possible to largely automate or substantially automate the production of these layouts based on the rulebook? So they actually did it formally. It went out to tender. We won it, positioning the value of our ability to implement rules in our rules engine, which is part of the 1Spatial platform. And it was very collaborative. We also had a local highway authority involved, sort of keeping a watchful eye, providing advice, and giving the nod as to whether we were getting it right, etc. Particularly where there is a certain amount of vague information in the Red Book, and you need the knowledge of the person in the street, and you sort of say, look, it doesn't really clarify what it intends here. How do you actually do this in practice? Northern Gas Networks would tell us, we'd encode it. Leeds City Council would say, yeah, that's right, or actually you should be doing it like this. So very collaborative project. The intent really was just to answer that question. Can we automate this by simply clicking on a map, maybe answering a few questions and having a plan produced from that? And it turns out the answer is yes. Actually, it is largely possible to do this. And on the right-hand side there, you actually see the prime product. So remember, this is use case specific. So the only thing we really want out of this application is the traffic management layout plan and the inventory list. And the inventory list is quite useful because not only does it potentially give you an idea of what it's going to cost you to potentially rent or buy or use this equipment, but also it's an inventory list for what you need to take out to site, but also gather up at the end of the project. Utility companies particularly get fined for every day and every piece of equipment that they leave out on site beyond the date that they were supposed to be there. Now, on the left-hand side, these are 3 examples from the Red Book of idealized road layouts. The reason I call them idealized is because they're always straight lines. in the book, but below those you'll actually see how it's implemented in the system. So this is all automated, and the great thing about this, you remember I said it takes between 30 minutes and 2 hours, or sorry, 2 weeks to produce, and actually can cost quite a bit of money as well, depending on how you account for your time. A lot of people don't account for everybody's involvement, but we've worked out by sort of testing the market that there's pricing range anything from about £35 if you don't cost in everybody's time and it's a really quick plan, through to £250 a plan if you do cost in everybody's time and you potentially have a capital cost because it's been outsourced to a specialist provider. So those 3 examples just show what's produced, and it takes, we found in the prototype project, it actually takes about 35 to 50 seconds to produce one of these. So even if it's not perfect, you've got a draft in place extremely quickly, and then can make a few manual edits to add a few more signs, move them, following input from the local highways authority. We are doing some clever things. We are doing things like line of sight as well, and just checking that we can. So for example, that layout in the middle doesn't necessarily require lights, but the line of sight suggested that it did need lights. So we have lights go in there. So very highly automated, as I say, 35 to 50 seconds. It went down well, that particular project. It went forward for a couple of awards and actually won. So as an innovation project, and the reason nobody's done this yet is it's really quite hard to do, and that's why it's typically still done in CAD as a drawing exercise. It's because it's a complex rule set and a lot of data needed, and quite complicated to implement. So that means that coming soon to a cloud near you, we've decided to look at a more generic version of this for the market. So this is our very purpose-specific app based entirely on our 1Spatial platform, sitting in the cloud, potentially charging people as a service per plan. So very straightforward. We ask the user to identify where they are likely to do the excavation. We answer a few questions that you cannot otherwise get out the data. It just doesn't exist, or it's the sort of information that you have to enter specific to the conditions at the time that you are planning your works. And the output is the map and the inventory list. And we're basing it all on all of the latest wonderful products from the Ordnance Survey. So Carsten will be showing this in a little bit more detail, I suspect, but the Ordnance Survey are moving more and more of their digital products online as a service. So we just consume those. They're absolutely fantastic. We just bring them in. We've got the different view scales of them, more and more detail as we zoom in. Then we start bringing in the features because we're actually using some of the data, particularly in the highways, with routing and asset management information data products. So we use that, and a lot of what we do with the layouts is very much a lot of geometry calculations, but there's some extended data in that we use as well in the highways data, and we relate out to the National Street Gazetteer, which is also coming into us via a service from GeoPlace as well. So very cloud oriented, brilliant data sets to be able to bring in on demand. And as I mentioned, we ask the user a few questions just to make sure that we're implementing the workflow correctly that's governed by the Red Book. So the user steps through those. And, oh, it's giving you too many sneaky preview there, which was unintended. But we ultimately are producing the plans. And I mentioned earlier about those who do and do not have the right to dig a hole in the road. If you're in a supply chain and you're a contractor, you don't actually have a right to dig a hole in the road. You're always doing it for and on behalf of somebody else, a statutory undertaker. We don't preclude those users from the system. In fact, they're likely to be one of the bigger user communities of the application. We allow them, though, to maintain a list of the statutory undertakers for whom they do work, and they can build that list up and apply it to the plan. And this final slide just shows you that because we're generating data with this app and from our 1Spatial platform, it means that it's not a huge stretch, and this is actually very soon on the product roadmap. It's not a huge stretch to be able to go out into the street and generate these things within the context of sort of 3D and augmented reality. So anyway, that's just a little flavor of one of our business apps, a very purpose-specific use case that's built entirely on our 1Spatial platform in the cloud, software as a service, pay per use. So thank you very much for listening. That's me.
Thank you very much, John. Thank you very much for that. So now what we'll do, we'll just move on to our final presenter for this morning. So I'd like to introduce you to Carsten Ronsdorf. Carsten is a strategic propositions manager at Ordnance Survey. Carsten's been working closely with 1Spatial since implementing Ordnance Survey's positional accuracy improvement program back in the early 2000s. He's focused on creating value, shall I say, from findable, accessible, interoperable, and reusable geospatial data. Before I hand over to Carsten, I'd just like to quickly outline what Carsten will be talking about. Carsten will be talking to us about a 1Spatial platform data partnership example. Partnerships are typically scenarios where there is a need to ensure that the 1Spatial platform connects with other platforms for the purpose of managing and sharing data. Partnerships are a key aspect of sustainable digital worlds. Organizations need to share data, working across system boundaries to consistently transform, validate, integrate, and publish data. Ordnance Survey's Digital Asset Hub and 1Spatial's platform provide access to a data pipeline. Ordnance Survey's platform provides a secure and scalable data sharing platform using open standards. By combining Ordnance Survey's and 1Spatial's platform provides a means to integrate input data and present data to users. And the example that Carsten will be talking to us this morning is about the National Energy System Map, which is driving quality and consistency for data access. Over to you, Carsten.
Yeah, thank you very much. Thank you very much, Matt. Very good morning to all of you. So I'm going to talk about three different things. So I would like to introduce the problem that we're trying to solve around data sharing platforms to start with, then talk a little bit about processes in a platform we've built called the Digital Asset Hub, which is a data sharing platform, and then apply this to an example, which is the National Energy System Map. Yeah, thank you. If you can advance the slide. So this is a slide I came up with maybe 10 or 11 years ago. You can see that it's quite old because it still has the old Ordnance Survey logo onto it. And what it's trying to say is that whenever you use geospatial information technology, you typically want to solve some kind of business problem. And in order to do this, you very often have kind of your own data set. So for instance, if you're in a local authority, you might have a terrier data set that you use in order to manage your land holdings. And what you typically get from OS, there's a little bit of animation there. If you can do three clicks, I think, on the slide, is that the coordinate reference framework that would typically come from Ordnance Survey. The geometric building blocks in the sense of the OS master map topography layer would come from OS, quite often from OS. And you would also need kind of meaningful real world objects. So what I mean with this is that not necessarily the building blocks in terms of kind of parts of your front garden or parts of the pavement, but things like functional sites like hospital, schools, and these are things that you want to know about. And that means that there is a lot of richness, obviously, in the Ordnance Survey data that I guess many of you are. But you will also hold business data yourself and think about accessing this business data. On this slide. Okay, one more. You could. One more, please. To the next. Yeah, great, thank you. So, the supply of ASPs together, so that's reference performance survey and business data from one of our more organizations. We can't apply this to asset data, towards the asset data. And we've been working on for quite a number of years to the extent that majority of the asset owners as far as utilities are very and
Carsten,
found that
sorry to interrupt, Carsten, but we seem to be having some audio issues. Can't hear you very well.
right.
Do you have some headphones that might work better?
Is that any better?
That is a lot better, actually.
Okay, well, please stop me again if that
Will
happens
do.
again.
Thank you.
Okay, so we came up with 4 kind of aspects of what data sharing of business data and OS data would look like. So we wanted to support really the operational use of asset data for a variety of business processes. One business process we've just seen in terms of the traffic management applications, that might be an example for something like this. Utilities quite often have the need for quick access to data, particularly in the case of emergencies. So, for instance, a water utility in the case of a burst pipe. There's quite often the need really to integrate data from a variety of different sources and bring that together. And then at the end of the day, there's a need to put the data into the fingertips of end users. And these could be field engineers, as the one you see on this image, or perhaps planners that would work out of the office. Next slide. Great. So one of the really particularly interesting projects or fields that we've been looking into is the energy market and the changes in the energy market and the energy systems that we're going to see over the next 10 to 20 years. So particularly with the move towards a net zero carbon economy and move to a net zero energy system, there are really big changes in the making, particularly when it comes to electricity, but also gas. And in 2018, there was a fairly fundamental government report from a group called the Energy Data Task Force, who looked at the digitization of the energy sector and the use of data and the need of energy data. And this group came up with 5 different recommendations that the energy sector should be digitalized, that data needs to be the value of data should be maximized. What they described as the visibility of data is basically a catalog that would allow people to find what data is available. With asset registration, they mean assets like smart meters and solar panels and where they are, where there are currently no definitive registers for, at least not for part of them. And then to increase the visibility of infrastructure and assets. And that basically means to create what is called the digital systems map, in which all the energy networks, gas and electricity networks in terms of the pipes and cables and substations and valves and so on, would actually come together in one consolidated view for the entirety of the UK. And this is the use case that we're going to apply the digital asset hub concept to in a minute. But before we do this, if you go a little bit further ahead to the next slide, let me quickly talk about the digital asset hub as an approach and as a piece of technology. So this was developed at Ordnance Survey over the last few years in order to create a data sharing platform that would bring together a variety of different data sets from different asset owners, could be local authorities, could be private utilities, could be central government organizations. And what we wanted to demonstrate is to bring data together and to show how additional value from this data could be created in order to show people to see a better place. Next slide. So in order to do this, we formulated a particular approach, and that was really based on the creation of a secure and scalable platform infrastructure, and the idea that a trusted data broker, facility and organization was needed in which data could basically be managed and come together and then distributed to the organizations and people who would need it. We also took a decision that from an approach perspective, we wanted to co-create this solution with users to ensure that for whatever business processes we would be working on, we would provide the right information. The data sharing part is really based on open geospatial standards, so that would allow pretty much any system to connect into this and provide a great level of transparency when it comes to from a data management perspective, and looking into the future to upgrade the system and evolve the system going forward. We also figured that we needed to put in quite a deep understanding of data integration and harmonization techniques in order to bring data together. And we really worked with this in a combination between the data modeling approach that comes from Ordnance Survey, which is roughly modeled on the OGC and ISO TC211 standards and the implementation that we've seen in the European Inspire directive. So we basically taken this data modeling approach and used it in this context. And then from a data transformation perspective, this is exactly where we're making use of 1Spatial and their insights and technologies to transform data, with then the view to create quite quickly a fairly complex data ecosystem and make this easy for the end users, but also the data provider. Next slide, please. So the first question you really need to answer is how do you get data into such a data sharing environment? And on the left-hand side of the slide, you see a number of potential data sets, asset data sets that could be on a local level, on a regional level, that could be from devolved government organization or from national organizations. And we worked quite closely with 1Spatial to really create this data pipeline, this workflow to make data available into the digital asset hub. We're making use of one data gateway, one integrate, as well as FME in order to process the data, to analyze the data, and give quality feedback of the data and transform it into a suitable format so all the data could be integrated and accessed in a consistent way. So then the data is stored in the system and then made available into a user portal. So this is basically how it works. So the 1Spatial elements are more on the left-hand side when it comes to the ingestion and analysis of the data, and Ordnance Survey would provide the data management and access technologies. Next slide. Okay, one more. So our experience in terms of the National Energy Systems Map. So I'm presenting this on behalf of the Energy Networks Association, who is the sponsor for this project, and it's an organization that brings together the network operators in gas and electricity around the country. So there are 17 license areas for gas and electricity. And as a response to the Energy Data Task Force report that I showed earlier, the ENA have created a subgroup for an ESM, an Energy Systems Map. So that happened 1 or 2 years ago. Last year, they worked on creating a couple of demonstrators. Following the successful implementation of that, they engaged in with a larger group of stakeholders amongst their membership. So basically, all the organizations that come together in ENA. And what we're currently doing as a project, which started in January this year, we are implementing a proof of concept, which is currently in development and will be launched at the ENA conference in October this year. Assuming that this will be successful, the ENA is then looking at a full-scale implementation, I guess, starting in 2022. Next slide. So in this project, we're looking at 4 different use cases and trying to answer questions about assets. What assets are there? Where are these assets? Who owns these assets? What is the capacity of the assets? What is the utilization of the assets at certain points in time? With that, you can speak about the performance of assets, and what opportunity means. These are kind of connection opportunities. So the 4 use cases that we have allow questions like, I would like to build a solar park somewhere. I maybe have 4 or 5 different target sites in the country, but is the electricity network actually strong enough in all of these five potential sites that I can connect my new solar farm to this energy, to the energy grid? And if you go to the next slide, please. This information need is currently served by the various network operators in a different way. So they all publish their individual assets and maps that show the capacity and the utilization of the network. If you click 2 more times, we see a couple more examples. And they all use different technologies, and visually they're all different, and the information content of these maps is all different. And the idea is really to find the lowest common denominator between those different maps. That is something that we've agreed with the participating network operators under the guidance of ENA, and then integrate the data from the 17 different license areas in the country into one single map for the United Kingdom. Next slide. So to give you a bit of an insight about how we're actually doing this in terms of the project, how it's unfolding, we're having 3 different work streams. There's a very important one on the legal framework, where we're working with legal agreements such as data exploration licenses and data distribution agreements that will allow us to publicize the asset owner data. So we are putting that in place. We're working on the functionality of the end user application itself. So this is specific functionality to serve the use cases, as well as user roles, and different user roles allow you to utilize different functionality and you look at different data sets, as well as then the data normalization work, where we are taking the data from the network owners and processing it so that we can integrate this into one single map. And on the next slide, you will see a very similar workflow to the one that you've seen before, this time with a bit more information about what we're actually doing in this project. So we're taking data in on the left-hand side from a variety of gas and electricity providers, then using 1Spatial in terms of the one data gateway and one integrate products to analyze this data. Feedback about the data quality is given back to the network owners with a view that they could then, at least in the medium term, improve the quality of these data sets. And then we're putting them, we're storing the data in a data management system and exposing this national energy systems map that users can access through a web interface. If we go to the next slide, we'll see a number of characteristics. So what are the things that make this approach or this data platform approach work? And we found it's really, we need really an engaged stakeholder community in order to do this. So it's not really about handing over data and then forgetting about this. So we really very actively consulted with the utilities about how the data could be integrated, what was in the data, the information content of the data to start with, and how the user stories would pan out in terms of accessing the data itself. So lowering the barriers for participation was a really important one. And I think that happens both on the left-hand side, where the data is being put in, as well as on the user side towards the right-hand side from a tool perspective, from an application perspective. And one of the challenges really is to make it as easy for the network operators to provide their asset data into such a system. And in initial discussions, we figured, well, should we come up with a common standard that everybody needs to provide their data into? And we pretty much decided against this. And what we've implemented is a scheme in which we're working with every single network operator to have a look at their data and then agree the data input format and structure with the network operator in order to make it as easy as possible for them to serve data and make data available into this into the National Energy Systems Map, which is then a process that's actually repeatable. And again, this is where 1Spatial and their expertise come in. So the actual data sharing platform has been developed in a way that data is accessible anytime and anywhere, including on mobile devices. We created this automated workflow of data integration and harmonization. Through these processes, we can put a certain level of quality improvement to the data, but we're also giving feedback to the data owners to start with, and then everything is wrapped up in a secure and scalable, resilient application environment. So the last slide shows a summary of our experience to date. So with the idea of a digital asset hub, it's really this secure and scalable solution that that can squeeze additional value out of geospatial data by making business data findable, accessible, interoperable, and reusable. And in order to make this happen, we found it's not just an application issue, it's really what I would describe as a data pipeline issue. So we need to connect into the information resources that sit within the original asset owners, make it as easy for them as possible to provide their data. And it's a very important principle. We're not asking the asset owners really to change any of their data management or any of the data in order to service the National Energy Systems Map in this example. We're basically trying to pick up the data in the format and structure that they can provide it in, and then integrating this into a common system. So the last slide just gives you a hint of the launch date of the National Energy Systems Map, which will be at the ENA Infrastructure Conference, which is called Low Carbon Networks and Innovation Conference, which is going to happen between the 12th and 15th of October this year. And in case you're interested, the URL is lcniconference.org. Thank you very much.
Thank you very much, Carsten, for that. Appreciated. I would just like to, before we conclude, just got a couple more slides just to wrap up. But before I do that, I'd just like to firstly thank our presenters this morning. So I'd just like to go back to the beginning and thank Dan Warner, Seb Lesware, Bob Chell, Bill Ridley, John Hartshorn, and then Carsten Ronsdorf from Ordnance Survey. So thank you very much to all of you this morning. We've just got a notice board, so there's a few points here that I'd just like to make with regards to what we've got coming up that might be of interest for you. So please look out for these forthcoming announcements and releases. We'll shortly be releasing the Police Data Quality Hub. We'll also, as we were seeing this morning, the 3D capability in the 1Spatial platform, so that will be released very shortly. We've been also working on a series of books, and the next series of books, as far as the little book of, is focusing on spatial data infrastructures, which we know that many organisations across the public sector are looking to evolve and maintain. Many of you might have seen already our new podcast series. We've just gone live yesterday with the third of those podcasts. And that podcast is very much focused on machine learning and artificial intelligence. So please take a look at that if you're interested. We'll also be broadcasting shortly a 3D geoinformation event. And also, as we've been doing this morning, we'll be also hosting some future government events focusing on the 1Spatial platform. And then also, if you're interested, then what we try and do is publish on a regular basis technical blogs about the 1Spatial platform. And shortly we'll be posting some blogs about 1Integrate and FME. So there's a few things there on the notice board that please take a look out for in the next couple of months. Another plug really that I just wanted to mention now is 1Spatial's annual conference, which will be this year will be a combination of a face-to-face conference and also an online conference. So it will be taking place over 2 days, the 10th and the 11th of November. And the face-to-face event will be taking place at the Royal Institution in London. But then we'll also, as I said, we'll be running the Smarter Data, Smarter World conference online. So if you're interested in that, it'd be great to see you there. Registrations are now open, so you can click on the, I'll go to the URL, which is on this slide, and then you can register for the Smarter Data, Smarter World conference. I'd just like to kind of put up a final slide, which is just some contacts. So if there's anything that you've seen from this morning that you would like to discuss in more detail or find out more about, then please contact one of my colleagues on this slide. So either myself, Matt White, Fiona Newson, Bill Ridley, or Dan Warner from the government team. And finally, I would like to say thank you to you all for taking the time and effort to join us this morning. Hopefully you found the webinar informative and you know more about the 1Spatial platform now than you did at 2 hours, well, just under 2 hours ago. So on behalf of 1Spatial and Ordnance Survey, I would like to thank you for attending today, and we shall hopefully see you soon. Thanks very much. Bye-bye.